Alright, so let's do a similar problem set. So now we have a study and it found that 65% of all the people have either the disease, statesis, or statesis symptoms, which is that the union of the disease and the symptoms is 65%. So the combination of the yellow and the blue bubble would assume 65% of that area. So 30% have the disease and 50% have the symptoms. Okay, so now we can use again the same logic as before. So we know that the union of disease or symptoms is equal to 0.65. And we know that 30% have the disease and 50% have the symptoms. Okay, so now we know that obviously the events are not mutually exclusive. So now we can write that the probability of disease or symptoms is equal to the probability of the disease plus the probability of the symptoms minus the probability of disease and symptoms. And we know that this is 0.65. What other information do we have given? Probability of disease, that's 0.3. Probability of symptoms, 0.5. So that means that this term, the probability of disease and symptoms, that must be 0.15. Okay, so here we have 15. That means here we have another 15. And here we have 35. Okay, symptoms and disease are mutually not exclusive. No, you can have them both at the same time. So they are not mutually exclusive. Assuming that symptoms and disease are independent, what is the probability of having disease and symptoms? So under the assumption of independence, we would say the probability of disease and symptoms is given by the probability of having the disease times the probability of having the symptoms. So those are the assumptions under independence. Okay, that probability of disease 0.3 times 0.5, so that would be 0.3 times 0.5 or 0.15. Assuming that the symptoms and disease are not independent, so that the probability of disease and symptoms is given by the probability, probability of disease times the probability of symptoms given that they have the disease. How much is that one? Well, the probability of disease, that is still 0.3. But now, given that they have the disease, so that means we have to limit our analysis to this yellow bubble. Well, 15 of those have the symptoms, so that's 15 over 30, so that's also 0.5. So we get the same result. So what is the probability that somebody has the symptoms given that they have the disease? Well, that's 50%. Assuming that symptoms and disease are not independent, the joint probability is, well, that's the same thing, we have that already, so that's a replication. Okay. What is the difference between the joint probability of selecting a person with both disease and symptoms under the assumption of independence and dependence? Well, there is none, because they are the same. So there is none. So therefore, because the probability of having statitis, given that someone has statitis symptoms, is not any different than the probability of having statitis without any knowledge about possible symptoms, such as that statistically symptoms and disease they're definitely independent, we have proven that, and they are mutually not exclusive, so D is the right answer. Okay, so let's stop here, and then let's continue with a couple of more exercises in the next video.